So, good morning everyone. Today I will present on beam deflection satellite solar panels. Satellite work in space for many years. There are a main power source is solar panel, and their panels is very big, thin, and lightweight. While the design helps them to collect more sunlight, it also them flexible and easy to bend. The bending called and deflection. If bending is not controlled, the satellite may be lose power, even they get damaged. That's why the study is deflection is very important for mission successful. Now we see role of solar panel. Solar panel means it's like a heart of the satellite. They convert sunlight into electricity, and the electricity power all system communication, navigation, and scientific instrument. Solar panels light satellite can't survive in space for long. Panels are designed to be lightweight, must cover large surface area. The balance make them efficient but also weak against the bending. Example: the International Space Station means ISS has a one of the largest solar area in space. Each area is along the football ground, which shows how important the big these planes are. Now we see what is deflection. Deflection means is a bending or displacement of a structure when a force is applied. In satellite solar panel, we have a like long thin beams. A small amount of bending is normal, but if bending become too much, can it cause power loss, crack, or even failure. So engineers always calculate how much bending is acceptable and design accordingly. Now we see cause of deflection. There are three main causes of deflection in space. First one is launch vibration. In launch vibration during rocket takeoff or lift off, the satellite experience very strong vibrations and shocks. Second one is thermal extremes. In orbit, satellites face hot sunlights and freezing shadows again and again. And the third one is when the satellite change position, communication and population force acts on the panels. Suddenly they long flexible can start oscillating like a thin rulers. There are three reasons make deflection analysis critical. Now we see why analysis is important. Because of ensuring the structure safety to make sure panels don't break during the launch or orbit. Second one is maintaining power supply. Uh, Solar panel must be always face to the sun properly. Means the sun face and solar panel face is both are same angle or it's perpendicular. If they bend too much, they may not generate enough electricity. When a sun position is like this and the solar panel same perpendicular to the sun, when its solar panel is like this, they don't make proper electricity or more electricity generate. So and third one is mission success to longevity. By controlling deflection, the satellite can work reliable for many years. For the example of this is India Mars orbit mission. That is we call Mangalyaan had to work in deep space with only limit power. They have only limited power and strong stability solar panels we the generate lasts much longer than planned. Now we see about the factor affecting deflection. The amount of bending depends on several factors. Panel length, longer planes bending more easily. Thickness is thicker panels means thicker panels are stiffer and bendless means when the smooth panel is bend easily bend and the thicker panel is not easily bent. And now we see material properties. Material like aluminum and carbon, those are high means high strength carbon or aluminum is high strength material, and also fiber, carbon fiber. Composite behave differently under a load. Applied load, vibration, and thermal stress are affecting bend. Now we see mounting conditions. How panels are fixed to satellite also controlling how much they move and designing shape. A well-designed bracing or support structure can reduce deflection. They reduce deflection when the proper shape of the wing reduce deflection. And now we see method of analysis. Engineer use three main methods to study deflection. First one is analytical for now we see method of analysis. Engineer use three main methods to study deflection. First is analytical solution. Second one is finite elements analysis FEA. Third one is ground testing. In first one using beam theory and equations. In second one is computer model divided the panel into the same parts, allowing the complex stimulation of uh, those load can material and the material. Ground testing, it's physically experiment such as vibration table and the thermal vacuum chambers. By the combination of those three material, by the combination of the three material, his engineer can accurate prediction of the deflection. Now we see accepted outcome. What we accept about the outcome. The goal of deflection is analytic. The analysis is to first one is find out the maximum bending on a panel surface. What is the maximum bending or the of the panel surface? And now we see compare this bending with a safe limit, means what kind of the bend we want, and this bending is safe or not. We compare, and if bending is within a limit, the design is considered safe and ready for launch. Means we consider it bending is good or safe, then this is ready for a launch. What is this? Next one is mission success examples. There are many examples. Like I give you two examples. First one is NASA, International Space Station. Its used solar panels continue to supply power for for because of careful deflection analysis. And second one is ISRO Mars orbital missions. Their panels stable in deep space ensure the mission lasted far beyond expectations. Both examples prove that without deflection analysis, long mission would be not possible for that. And now we see conclusion of this one of that like now we see conclusion of this. So in conclusion, solar panels are initial for satellite, but because they are large and light, they can't bend easily. But analyzing deflection, engineers make sure panel is remains safe or not, generate power perfectly or not, and help mission success. And thank you for listening and watching this video.